Hello, my name is Gleb Bahmutov. I'm not Matthias. So if you want to know about animations, it's there. I'm here to talk about performance and turning it all the way to 11. And 11 is a reference to the movie called This is Spinal Tap. And you will see why 11, just because some of the hacks I do will be ridiculous and no one should do them. Anyway, I work at Kensho. We're a startup. We've been around for 2 years. We do financial analytics. And we work in beautiful Cambridge in Boston. And we also work in World Trade Center, right in the middle. We also have a San Francisco office, but I haven't been there, so I don't have a picture. And we have an app, and the app does a very simple thing. Let's say you have an idea, and you think during Olympic Games, because there's so much advertisement, I should buy Nike stock. So we just allow you to analyze that and show you the data, and you can validate your hypothesis. So we have an app. It's an Angular app. We've been developing it for 2 years. And we were trying to show more and more data. And you can see there are styles, there are grids, there are charts, and stuff like that. And we hit performance problems. And we started searching for solutions. And every time we solved a solution, I would describe it in a blog heading to what they searched for. I don't want to say word Googled, I want to say bang. It would be at number 1. It kind of dropped now, but there are a lot of insights. And the most important insight, that's the easiest, is just upgrade your Angular version. There are constantly performance improvements, right? That's the easiest one. The second one is you probably have too many watchers, right? And you should use track by, because if you change the order of things in a list, you don't want to redo the DOM. And if you use track by, Angular can help you. And if you have a lot of filters, like you compute dynamically the color, just pre-compute it once. And of course, limit the number of elements you're trying to show. Maybe use a virtual scroll. And I was looking at this list, and I was like, well, it's all good, right? And these are all valid techniques. But how do you go about the performance optimization? So in this presentation, I want to actually show how I find the problem and how I fix it. And now the moment you've all been waiting for. Oh, no, before that. So I'll show live app profiling, a couple examples. I will revisit Angular plus React equals speech or presentation from ngconf. And then I'll talk about my personal failure and how I found redemption. And now the moment you've been waiting for, primes. So I have a small app, and it will find your primes. And everything is fine, right? Like, you're happy. You can find 100 primes easily. Oh, 101, no problem. So you wrote this app. It's an Angular app. It's very, very simple. There is a button and ng repeat. And everything's fine. And then someone says, well, if I try to search for 1,000, well, everything is frozen, right? I mean, I can scroll, but the browser is frozen, right? This is when I actually start profiling and performance optimization, not before. Right? So it's important for the user to come to you and say, this part of application is slow. Right? Don't prematurely optimize. So here's the great part about Angular. So I open a browser. I have my application running. Let's change to 10. And I can grab scope for any element. Right? So let's pick the button. So Angular element 0 scope. Let me maybe minimize this so people can see it. Excellent. So it's a simple object, right? That's the great thing about Angular 1. Your scopes are nothing but plain objects. So this means that we can actually find this method. It's right there. This means that we can use things like monitor. And every time we click it, right, the browser says, oh, you ran that method. It's nothing but a JavaScript method. If you're not sure where the method is actually located in your source code, well, it's easy to say debug, and whenever I click find, boom, it's right there. So I can continue. I can disable these things. And and monitor. I can do even weirder things. I can say find new function, and I can replace the source code. No primes for you. Right? No primes for you. Right? Angular is nothing but a plain JavaScript application running connected to your DOM, which is great. Because now I can take my methods that I can access from a console in a live application, and I can use something called code snippets. And if you never use code snippets, they're great. They're like little bookmarklets that you can store right here in your application. And they allow you to just enter any JavaScript, let's say Angular version. And if I run it, it runs in the context of my page. So just a piece of JavaScript that you save for later. And I started a repo of useful performance code snippets. There are general ones, but there are a lot of Angular-specific ones. And the cool thing, let's take one of them, is called profile scope method. And what it does, it finds a method by selector and then by name. So everything I've done from a console, it can do for you automatically. So my button is called find, and my method is called find2. So if I run this, this will actually replace that method with a timing code. And so when I click, I should probably reload. 1000, rapid. And so what it has done, it replaced my method in a live production application with something that instruments and actually starts a profile. And whenever this finishes on my MacBook Air, it says it ran for 14 seconds and it saved a profile. And now I can inspect and I see every method. And the best thing is I can switch to a heavy and find my top bottleneck. Okay? And you see this little warning sign that says try catch statement. That's why it's not optimized, because I actually used try catch. This is actually one of the reasons why Angular digest cycle is slow, because it's using try catch to catch the errors. So use code snippets, access Angular from a console. It allows you to do a lot of things. Just to show what it means for try catch. So it ran for 15 seconds. I don't have a slide for that. But if I remove this, and if I go to the next, check out step 1. So the entire difference in this application is that I removed the try catch, and I will profile this again. And if I run this, then it should take less than 15 seconds, 5 seconds. Okay. And if I go to profile and I compare my is prime that used to run for almost 15 seconds, or 10 seconds, right? The difference? Yes. Or 13 seconds. Runs now in 26 milliseconds. Again, I'm using code snippets so that I can accurately measure how long things run. Before you can optimize anything, you should measure it. And Angular, by using plain JavaScript object as my scopes and methods, allows you to accurately measure from the outside without modifying the production code at all, which is great. Some more examples. So my profiling rule. As you noticed, I switched to Chrome Canary. I'm using a different browser, so that no Chrome extensions, nothing affecting the performance. I profile the actual application, not the little benchmarks, they're useless. And always try to concentrate on the top bottleneck. Don't try to optimize something you think will matter if it's not shown to be the top bottleneck. That means you have to re-architecture your code a little bit. Just like you want to re-architecture your code to be testable, you want to re-architecture your code to be profilable. Like your cars, right? They all have this little port where you can plug in a sensor and read all the sensor information. Think of your code as having a port that you can hook in from your console and kind of wrap and measure. And interestingly enough, there is a company called Automatic that sells car adapter with a logo that looks exactly like Angular. What a coincidence. And another interesting fact that I read is that the first car that had a computer with a sensor was Volkswagen in 1968. So they've been planning it for like 40 years. So my asynchronous methods, even if I don't have to, return a promise so I can hook into that promise from a code snippet that I just showed. If you have messages passing, you might have to re-architecture the code a little bit and get a promise for those cases. So a little bit more boilerplate code, but makes it easy to debug. And now, my personal pet peeve. At ngConf, Aaron knows, there was an excellent talk by Dave Smith, who was just showed great stuff. And he compared Angular 1 to React, and it takes forever for Angular. So let me show you that example. So all it does, imagine it's a calendar, right? It has each hour for every day of October, so more than 700 cells. And if I click on a cell, it actually computes, it simulates Ajax. And then you want to do it for every cell. So if you click a button, React runs, updates everything. And the same thing with Angular 1. So the same thing, but if I click this, I have to refresh the browser manually. It just runs forever, right? It is so slow. And so here's a problem. How do I approach investigation? So let's first look at what's taking so long, right? Let me load this. And I have another snippet that just profiles how long an idle digest cycle runs. So in this case, 25 milliseconds. That's way too long. Like nothing is happening in this page. Why does it take almost 30 milliseconds? So I have another code snippet that finds all the watchers. So 5,000 watchers just on this table. Well, but that doesn't really explain why the table load takes forever, right? So here's another code snippet, and all it does, it tells me how many digest cycles are running. So if I click this, so here's our problem. We're actually running digest cycle every time a particular cell updates, right? Because Angular hides all these details for you, right? So every time you click something or you run HTTP or return a promise, the whole digest cycle executes, and then everything recomputes. Even if you change this particular cell, the whole grid kind of checks itself, and this is obviously the slow part. So what can we do about this? So let's look at the code. So this is a code for a particular cell. And it simulates an Ajax call by using a timeout. And the great thing about all the wrappers that Angular team created is that they sometimes have hidden parameters. In case of timeout, there is a third parameter that no one knows. And if you set it to false, so by default, the third argument is true, which is counterintuitive. And it's like, should you run the full digest cycle after the timeout? Right? And so if you set it to false, that particular cell will not update everything because it knows nothing has changed outside of me, so it will just update itself. So let's see. So I have the project running. It rebuilt itself. So let's load. OK. And I will show the number of digest cycles. Oh, I'm already done. OK. Well, that was fast, right? Oh, by the way, searching for watchers is called searching for Sasquatches. Anyway. OK, did you catch the performance optimization? I mean, just. So my clone of a repo is where you can look at that. Well, you can say, well, it's not really fair because he's actually simulating HTTP call. But HTTP call also has the same option that combines the digest cycle so that you don't run it on every cell. But if they all arrived within certain threshold, only a single digest cycle runs. So well, the framework supports this kind of optimization. So blah, blah, blah. I posted. I was hoping the initial load speed would be more central to the discussion. Well, first of all, Dave, this is pretentious. And second of all, OK. And he's right. If I just look at this, how long this initial table takes, right? Like there's noticeable pause for Angular, which doesn't exist for React. And so I profiled the Angular grid load, and it takes longer than half a second. And this is on MacBook Pro, I forget, probably MacBook Pro. So on Angular Air, even longer. And look at the flame graph, right? It's all kind of very checkered. That means the framework is doing different things. It has to compile a directive and link everything. It has to create the element, all these things. And look at the profile for React. It's very clean, right? It generates virtual DOM for everything and then renders in a single shot. Cool. So the whole table is just 2 ng repeats. And here's what I really think. That if Angular team did not include ng repeat in a core framework, we would not be talking about Angular performance problems at all, right? If it were like third-party extension, you would be like, oh, this grid plugin for Angular sucks. But Angular itself is great. This is a huge mistake. So I've done typical ng repeat tricks like track by, single one-time binding, nothing. And then I thought, well, maybe the creation of particular element for each cell and then linking it right away into the DOM makes layout computation. And so I wrote boom repeat that creates everything but doesn't link until the very last second. Nothing's helping. And then you're probably guys wondering, Gleb, you delivered an awesome talk at ngConf. What were you being up to? So at ngConf, I showed how to run the digest update in Angular 1, but inside the web worker for speed. After I finished the talk, I made the whole Angular 1 running in web worker. And you can read how I've done it. The code is all up there. So basically, I took the JS DOM, which is synthetic DOM, and I ran browserify. That makes no sense, but it works, right? So you take Angular from a browser, and then you add synthetic browser for Node, and then you convert it to run back in the browser, and you remove all the Node parts, and so you get a bundle. OK, good. So now I decided I have to generate this giant grid. And what if I can run multiple web workers, and each web worker is running Angular, and I'll give it part of a task. Like, hey, you generate just these 5 rows, and you generate the next 5 rows, and then you send me results, and I'll combine them. So you press load, and I start, how many web workers, 4, 6, whatever I think is necessary. Each one is running the full Angular 1 app, right? So no special tricks. And then each one sent the update, and I displayed them. And as you can tell, this failed so miserably. Machine I ran, maybe 10% better, but usually the same. And the thing is because I use synthetic DOM, which is actually slower than the real DOM, right? But this just shows that Angular 1 needs the browser, right? It needs the element, right? Running it inside a web worker where there is no environment probably makes no sense. And again, well, Dave replied. And he kind of uses like double negative. So what he really means here is let's look at the big picture and let's not like use hacks like I've done to actually go against the grain, against the web worker, or against the framework's intention. And so this was my failure. And this is my redemption. So we're talking about performance, and we're talking about the speed. And I think when we talk about the speed, we should also include how long it actually takes to develop an application and how long it takes to maybe refactor an application and then bootstrapping and running performance. And here's where Angular, I think, really wins than any other framework. Sometimes it's you, but usually it's a designer. And he comes back to you or she comes back to you and says, I want this. Here's my prototype. Maybe I have HTML. Maybe it's HTML generated from some prototyping tool. So you have just markup. And it could be done by designer. And then you add a few Angular directives, and you get a live application. Right? Just a few markups, right? And it could be designer or developer. And if you don't believe that designers could do that, well, you should read Lucas's blog post, Just Enough Angular for Designers. And by the way, everything in blue is a link, so in a slide you can follow it. And what happens next? Well, we have an application and actual users are using it. And when they complain about some particular performance problem, then a developer can come in and do track by one-time binding, first optimization. And if there is still problem, well, then you start thinking about your data and when the scope digest cycle runs, like I showed before. And so you do the second performance optimization if the first was not enough. And this is obviously done by a good developer. So if we look at UI, UX, right, an initial application development time versus performance optimization, we probably spend a lot of time here. Because features come and go, the UI layer changes a lot. And this could be all done by designer. Angular makes it so simple that the initial goal of wiring the application, of experimenting, of showing something to the client and then saying, yes, that's exactly what we need to build and optimize, can be done by a designer or someone with minimal experience. And once we know that we're building the right thing, well, then the developer comes in and works on performance. OK, so not kind of put a focus on React. You have to start with code. Right? It could have optimizations like JSX, but in reality, I cannot take a designer and tell him, build a React app. It would take way too long to teach all the programming skills. And think React is not the top of the line. If it were up to me, I would use like Reactive JX plus Virtual DOM, where the code is using all streams. There is no way a developer without training can develop an application quicker. And this is what Angular allows us to not run in the wrong direction, but very, very quickly. So this is the story of my redemption. I have not said Angular 2 even once. Well, first of all, this is track 2, so obviously track 2 is Angular 1 specific, and track 1 is Angular 2, which is the typical thinking from the Google team. But second, we've been building applications and we've been running them in production for 2 years using Angular 1. This is what we found to be problems, and this is how we solve them. This is how we go about solving them. Angular 2 is still in prototype stage. There are a lot of interesting experiments that show performance improvements, immutable data, removing the digest cycle, and so on. But once the Angular 2 is released, then we will see, and then we will see how it actually performs in production. So that's why there is no Angular 2. Thank you so much. The slides are out there, and I have a lot of blog posts. I'll be happy to answer any questions later.